This is Engineering 120, Section MO2 for the Engineering 120 Lab 2. I am Matthew Goodenough, and this is my lab circuit 2. So I'll start off by, so on the voltage supply, we have 5 volts. That's where we start off first. And then we will read it off of our multimeter. But here is the second. I'll set up the circuit now. All I do is plug in the power supply. And as you can see, we got power now. And then changing voltage, but that's fine. We'll switch it back. Sometimes you gotta tinker with it to get it back to 5 volts. But now we will take our leads to read the current being supplied to this circuit system. As we can see, we got our sections open to our open wires to read our power voltage from our power supply. And as you can see, it's around 5 volts. And we read that off our multimeter, reading voltage, DC voltage. And that's what our circuit is getting. And we can measure our resistance from our resistor. I believe this is the 2 kilo ohm resistor within this circuit. And then we got to go back onto our multimeter, switch it to ohms. You have to unplug the power supply and able to read ohms. So now this is a resistor we are using. It is about a 2 kilogram resistor. It has some percent error in it, but it's within the 5%, so we're good. And then now we can go back and read our voltage on the LEDs that's being supplied to our breadboard, our circuit. Oh, we can also read that's what I was going to do. I was going to read the voltage as well. So we know the resistance of the resistor. Now we go back to our voltage. We see, so now we read it from our leads. It goes through. Now we're getting around 1.3 volts of voltage at our resistor. Now we switch to the LEDs. Now we are connected to the LEDs, and an important thing when connecting LEDs, your longer end is your positive and your shorter end is your negative, so your anode and your cathode. And that's how these are hooked up from the long, so the power can go in and come out and circulate back to our circuit. And see, here we are reading 1.769 volts from our first LED, and we will check the other. So we are getting 1.889 volts from our second LED. Now we have to do 3 LEDs, and I will build the circuit real quick just to demonstrate. But for this circuit, power comes from our supply, goes from our purple. So my color codes, the blue is positive, purple is negative. So it goes through the blue, comes down, transfers, goes to the resistor, goes through our first LED, through back to the second LED, and comes through our negative ground back to the power supply. Let me build the circuit real quick. Okay, I built the third circuit. This is using 3 LEDs, and I did have to increase the voltage. I increased it to its maximum I used on my paper, which was 9 volts. So we can do the same readings again. We can check our voltage at our supply. We're still using the same resistor, 2 kilo ohms. And we go to our multimeter. We got about 8.92 volts. It's close to 9. There's some error in there, but that's okay. Now we'll check the voltage of our resistor one more time. And our voltage at our resistor is 3.334 volts. We'll check our voltage at each LED. The first LED is 1.43, my bad. And we'll check the second LED. Our voltage is 1.937. We'll do our last LED. Our third LED is 1.806. So this was our lab 2. That was the results. That's what I got from connecting the 2 LEDs and LEDs at the certain different voltages. And then you will repeat this process. You will repeat this process a couple of times using the different voltages, finding the voltage at this resistor, the LED, and you will also calculate the current from the voltage of the resistor divided by your resistance. And then also the relationship will be linear because it's constantly going up at a constant rate. And that is all for my lab 2. Thank you for listening, and that is all. So we just learned about how a DC circuit works in series and how it transfers through LEDs and the different types of equations to use to calculate voltage, resistance, or current. And that's all. Thank you.